All right, here we go. We're going to find exact values of any angle. Let's go. All right, so this video is going to be about finding the 6 trigonometric function values of theta given a point on the terminal side of theta. So let's check out the problem. All right, so we're going to find the exact value of the 6 trigonometric functions of theta. We're given a point that lies on the terminal side of theta. That point is -3, 4. All right, so what does that look like? Well, if we sketch the coordinate plane here, the coordinate plane, you got your y-axis, your x-axis, that looks familiar. And then we're going to let's take red and we're going to sketch the angle that we're looking for. So the initial side of angles in standard position always lie along that positive x-axis. The vertex of my angle is going to be at the origin. So I need to think about where that coordinate -3, 4 lies. -3 represents the x, 4 represents the y. So that coordinate is going to be in the second quadrant at the point -3, 4. So if I go over -3, go up 4, there's that coordinate. Coordinate? It doesn't have to be exact. We're sketching the angle, so you don't have to put the hash marks along your axes. You just need to kind of approximate where it's going to be. You're going to sketch your terminal side. So there's the terminal side of my angle. So theta is the angle created by the initial side and the terminal side. So boom, there's theta. All right, so now what we want to do is take that terminal side. Let's zoom in on it real quick. So now what we want to do is take that coordinate, that -3, 4 coordinate that we were given, and we're going to create a right triangle. How do we do that? We're going to connect that point, the -3, 4 coordinate, to the x-axis. When you bring that down, it creates a right angle with the x-axis. And so now if you look very carefully, we have this right triangle. So let's zoom in a little bit more and shave off the little extra stuff that we have. This little thing's mama left. You probably hear her scratching at the door. Hello, hello. You a good girl? Say hello to the camera. Say hello to the camera. Hello. All right, back to it. Hopefully she won't be too loud. So when we create that right triangle, we have 2 sides to that right triangle because when we move left on the x-axis to get to the coordinate -3, 4, well, that tells me that this side right here, she hit my arm. That tells me this side right here is 3. We did go left, so you can either label this -3 or 3. I like to say -3 because we did go left on the x-axis. That will make a little more sense here in a minute. We all know distances are not negative, but for now we're going to label that side -3. We're going to also label this side here +4 because we did go up to get to the coordinate -3, 4. Now we have 2 sides to this right triangle. We can find a third by Pythagorean Theorem. Now, if you work that out, you're going to have -3 squared. Now, a lot of people make mistakes here. Remember, anything squared is always positive. So if you type in -3 squared into a calculator, please put -3 in parentheses. Otherwise, your calculator is probably going to say -9. So you have to remember, anything squared is positive, right? So now we add the 2 together. We get 16 plus 9 is 25. And therefore, C is equal to 5. You take the square root of 25. All right. So now we have all the sides of my right triangle. We're using a right triangle to find the exact values of the 6 trig functions. And so anytime you have something involving a right triangle, remember soh-cah-toa. Soh-cah-toa is some old hippie caught another hippie tripping on acid. Just a way to remember, right? And we mentioned that in a previous video. If we want to find the exact values of the 6 trigonometric functions, we need to remember soh-cah-toa, and then we also need to remember reciprocal functions. So for the sake of this example, I'm going to create another angle, right? I know theta is this angle, but I'm going to look at something known as the reference angle to find these exact values. Hopefully you've been introduced to the reference angle. If not, I may make a little short video about finding the reference angle to particular angles, so look for that. But the reference angle, it's a positive acute angle that's created by the terminal side of an angle and the x-axis. And you label it usually with a theta prime or whatever the angle's called. In this case, we have the angle is the theta symbol, and so the reference angle is theta prime. So now we have everything we need. We're going to find the exact values of the 6 trig functions now. Sine, cosine, and tangent. We all have heard of those 3 trig functions. Cosecant, secant, cotangent may be somewhat new to you. To always start with the sine, cosine, and tangent values first, and then reciprocate those to get your reciprocal functions. All right. Soh-cah-toa is going to help us find the exact values of the sine, cosine, and tangent, and then we'll just reciprocate those for the other 3. So remember, sine is the opposite over the hypotenuse. That's what soh-cah-toa means. S-O-H, sine, opposite, hypotenuse. So we need to label this triangle based off theta prime. So if theta prime is that angle down there, then we'd say this side is the opposite, this side is the adjacent, and this side is the hypotenuse. It looks like I've erased my 3 on that side, or -3. So sine is the opposite over the hypotenuse. The opposite side is 4, the hypotenuse is 5. That's it, okay? Cosine is the adjacent over the hypotenuse. AH, adjacent hypotenuse. The adjacent is -3, hypotenuse is 5, so that's -3/5. We're going to talk about that in just a minute and why it's negative. And that kind of goes back to why I like to keep the side length of that triangle labeled -3. Tangent is opposite over adjacent, and so the opposite is 4, the adjacent is -3, and we'll just bring that negative to the top. Now the other 3 trig functions are simply reciprocals. And so remember, the reciprocal of sine is cosecant. So cosecant is 5 over 4. Secant is the reciprocal of cosine, and so that's -5/3. And then cotangent is the reciprocal of tangent. If tangent is -4/3, then cotangent is -3/4. Boom! Notice I use theta prime to find these exact values. That is very important. But what you will learn over time is the reference angle to a particular angle can be used to help find exact values of trig functions. Okay, so sine of theta is 4/5. Sine of theta prime is also 4/5. So I use that reference angle to help me find sine of theta, all right? Cosine of theta is -3/5. Cosine of theta prime is also -3/5. And that's just the idea behind a reference angle. Look for a short video, a YouTube short, in explaining the reference angle. I'll make that as soon as I'm finished making this video. But that's how you find the 6 that's how you find the exact values of the 6 trig functions, given a coordinate on the terminal side of theta. And so what I want to end this video with is looking at the signs, the SIGNS, the positives and negatives of these 6 trig functions. And that is going to bring us full circle back to why I label the side -3 for the adjacent. All right, so over here we have the problem that we just completed. And then over here we have the coordinate plane with ASTC written in the quadrants. Quadrant 1 is A, quadrant 2 is S, quadrant 3 is T, quadrant 4 is C. I like to remember this by the phrase, all students take calculus. All students take calculus gives you the order of the ASTC. But in terms of trig, what they help us determine is the signs of our trigonometric functions given where the terminal side of theta lies in. And so, for instance, our terminal side lies in quadrant 2. So we're going to look at the S quadrant. What I have written in red is sine and cosecant are positive, all others are negative. And so look at the rest of the quadrants that are labeled. If you have an angle whose terminal side lies in quadrant 3, then tangent and cotangent will be the only trig functions that are positive. All others will be negative. If you have a terminal sine line in quadrant 4, then only cosine and secant will be positive. Everything else will be negative. And then if the terminal side lies in quadrant 1, all trig functions will be positive. So that's what that means. And now that corresponds with this. Sine, cosecant are positive. All the others are negative. And if you go full circle, that's why I kept the side of my triangle labeled -3, and that way I don't mess up. I hope this video helped. I'm about to record a YouTube short talking about the reference angle. I'm going to use this same exact problem. So look for that, and I hope this helped.